Hello everyone, welcome back to my channel. My name is M. Ganeshmani, USN 1BE 22EC 056, pursuing my BE at Sri Venkateswara College of Engineering in ECE stream. The course name for today's video is Digital Communication and the course code is BEC 503. So by looking at the image itself, we can understand that today's video is gonna be about broadcasting. But in digital communication, it is going to be the modulation techniques used for digital TV broadcasting. So we'll be analyzing it. That is what today's content is for today's topic. So the contents that we'll be covering are, so first we'll be looking into the definition of digital TV broadcasting. So digital TV broadcasting is the transmission of audio, video and multimedia data using digital signals, which offers higher quality and better bandwidth utilization compared to analog broadcasting. Why modulation is required is because modulation allows the transmission of signals over long distance. It enables multiple signals to be combined and transmitted simultaneously without interference. So we'll be now looking into the types of modulation, and before that we'll understand what is modulation. Modulation is the process of altering a carrier signal to encode information for transmission. And types of modulation are QPSK, which stands for quadrature phase shift keying, QAM, quadrature amplitude modulation, OFDM, orthogonal frequency division multiplexing, COFDM, coded orthogonal frequency division multiplexing. So these are the types, and we'll be understanding it on the upper hand on the basis from one by one. So the first topic that we'll be looking into is quadratic phase shift keying, QPSK. So quadrature phase shift keying is a digital modulation technique that encodes 2 bits per symbol by altering the phase of a carrier signal. Unlike binary phase shift keying, which uses only two phase shift, QPSK uses four distinct phase shift, that is for 0 degree, 90 degree, 180 degree and 270 degree, to represent four unique bit combinations. For 00 stands for 0 degree, 01 stands for 90 degree, 11 stands for 180 degree, 10 stands for 270 degree. This technique allows QPSK to transmit twice as much data as BSK for the same bandwidth. The next is quadrature amplitude modulation. Quadrature amplitude modulation, QAM, is a digital modulation technique that combines both amplitude modulation and phase shift keying to encode data into a carrier signal. Unlike QPSK, which changes only the phase of the carrier signal, QAM changes both the amplitude and phase of the carrier to encode more bits per symbol. Example, 16 QAM, 16 bits, 4 bits per symbol, that is 2 raised to the power 4 is equal to 16. 64 QAM, 64 points, 6 bits per symbol, that is 2 raised to power 6 is equals to 64. 256 QAM, 256 points, 8 bits per symbol, that is 2 raised to power 8, 256. That is how it stands. It is further used for many applications, like for transmitting that data using Wi-Fi system or for satellite navigation. Also, this plays a huge important role in communication system of or transferring system of the digital signals. Orthogonal frequency division multiplexing, OFDM. Orthogonal frequency division multiplexing, where multiplexers play a role in order to combine various signals into one signals. So orthogonal frequency division multiplexing is a multi-carrier modulation technique that splits the data streams into multiple subcarriers, such as modulated with a lower data rated signal. These subcarriers are orthogonal to one another, meaning they do not interfere with each other despite overlapping in the frequency domain. The key characteristics of this is multi-carrier modulation. Data is divided across multiple subcarriers. Orthogonality. Subcarriers are orthogonal and preventing interference. Spectral efficiency allows for better use of available bandwidth. Resilience to multipath fading. Strong resistance to fading caused by reflection and refraction. There are many medical formulas. There are mathematical formulas that are used to provide that orthogonal frequency division multiplexing plays an important role in transmission of digital data. So the last type of today's video is coded orthogonal frequency division multiplexing, that is COFDM. Coded orthogonal frequency division multiplexing. It is a type of OFDM only in a coded way, in which the codes are different as compared to OFDM. These play a vital role in transmission of 5G network also, which is currently used, and later on in many other countries it is used for 6G networks and faster higher speed data, which is used in most of the companies to control supercomputers. So now let us understand about the coded orthogonal frequency division multiplexing, which is an advanced form of OFDM that incorporates error correction coding along the OFDM modulation. By adding forward error correction FEC to OFDM, COFDM provides greater robustness of noise and interference and multipath fading. It is widely used in digital TV broadcasting DVB-T, DVB-T2, digital audio broadcasting DAB, and mobile communication system COFDM. Significantly enhances the reliability of data transmission is noisy time-varying channels. So the key characteristics are error correction coding, uses error correction like convolution or Reed-Solomon coding to detect the correct errors. Frequency diversity data is spread across multiple subcarriers, making it more resistant to narrowband interference. Multipath fading resistance. Better resistance to multipath fading compared to OFDM. Adaptive modulation uses QPSK 16 QAM, 64 QAM or higher order QAM detectors in order to improve the channel quality. So these are some of the types of some of the advantages of COFDM. So now let's look into the advantages and challenges. So advantages first, provides a efficient data transmission, overcomes interference and noise, supports multiple users on the same channel, reduces bandwidth usage, more channels in limited spectrum. Now the challenges. Noise and interference. QAM is more susceptible than QPSK or OFDM. Hardware complexity. OFDM and COFDM requires faster Fourier transform, means the operation is very faster rate, so it requires a huge amount of hardware complexity. Next is high power requirement for both QPSK and QAM in order to use, and the signal to noise ratio, that is SNR, is also very high. So these are some of the advantages and limitations, and in future tense these might play an important role in satellite navigations, digital data transmissions, and also in TV broadcasting and networks such as 5G, 6Gs and 7Gs also, which are under still research. Thanks for watching this video. Please do like, share and subscribe to my channel. Hit the bell icon for further notification. Stay tuned for more upcoming videos. Goodbye.